So thanks for coming by. I hope everyone isn't too wiped out after a couple days and a big lunch. But my name is Mike Place. On GitHub, I am known as Cashed Out, C-A-C-H-E-D-O-U-T, which means hopefully you can put a name to a face, because I probably have interacted with a lot of you via the issue tracker or discussing various features or what have you. I've been a core engineer at Salt for just about 18 months now, and I work primarily, well, on the core, right? I work, yeah, weirdly enough, which means I work on the transport. Sorry, apparently there's a chair that's off limits. I work primarily on the transport, on the event bus, and making sure that things continue to be very, very fast. So if any of those things don't work, I am the guy that you should blame. All right. At any rate, this talk is optimizing and troubleshooting the SaltStack implementation. And I know many of you may come expecting a lot of silver bullets for troubleshooting the particular problems that you might have. I do not have a lot of silver bullets for you, but instead of providing silver bullets, I'm going to try to provide some knowledge about how things work, so that you can at least have a conceptual understanding of the moving pieces inside Salt, and so that you can go back and look at your own implementation and have a better understanding of where things might be going wrong if something is going wrong. And because I gave this talk yesterday and I ran out of time, we're actually going to go in a slightly different order than we did the last time, which basically means I'm more or less just going to ditch the slides because slides are dumb. So what I want to do, when most people talk about troubleshooting the SaltStack implementation, this is not going to come as news to you. The most common complaint that we hear is that returns have gone missing, right? You know, I did something, and you know, not all my minions came back. One or more minions, you know, came back. And so we're going to do sort of a fundamental, high-level architectural overview that takes us from the CLI, takes us on a journey from the CLI to the master, to the minion, execution of a given command, the return to the master, and the return to the CLI. On this journey, what we're going to do is we're going to break things down by sockets and processes and by actual classes. And so as I do this walkthrough and as I do this diagram, feel free, if you have the Salt code base up in front of you, it's on GitHub, obviously, to pull it up. We're going to start with the CLI, which is primarily what we're talking about will be located in salt.client.local client. Okay? So off we go. What we're going to do is we're going to diagram something very simple, right? Salt, my minion, see my handwriting is bad, right? Test.ping, okay? From a single master, sorry?
Do you have a black marker by chance?
I do. I will do the rest of my diagram with this black marker. Thank you for the suggestion. Salt my minion test.ping, okay? As we all know, we do this from the master, right? And so the first thing we do is we call the salt command, okay? The first fundamental thing to realize about the way that Salt operates is that all of the CLI commands are extremely lightweight wrappers around basically well-defined APIs, okay? For the Salt command itself, the well-defined API in question is called local client, okay? If you've looked at the code base at all, you'll see local client. It's in, like I said, salt.client.dunderInit, okay? Local client has the responsibility of taking an input, right, either from the CLI or anywhere else, right, and communicating that input to the master and waiting for returns, okay? The really nice thing about this is that you can actually emulate all of the behavior from the CLI in a couple of lines of Python, right? You can literally go out, generate an ops dictionary from salt.config, pass it into local client, and do a publication in probably 3 lines of Python, right? And that's the whole Salt CLI, right? Local client is sitting behind the scenes, okay? So what happens? When we fire up local client, we give it a couple of things, right? We give it some targeting information, right? What minions do I want to talk to, okay? We give it a remote X command, right? A module and a function that we want to execute. And potentially we give it any arguments, right? Okay? So the CLI does the following, okay? Okay. It first looks at all of those commands, makes sure that they're valid, okay? Does a little bit of pre-processing that isn't important for the purposes of this discussion, right? And then what it does is it kicks that that targeting information, right? The intended minion and the function over to the master, okay? The master, right, receives that information, okay, and then is going to reply, okay, back to, right, this is local client, okay, okay, is going to reply back with a list of expected minions, right, that the client should expect to return, okay. Now, one of the themes that you're going to hear me talk about again and again as I do this overview, right, is that Salt is fundamentally asynchronous at every place we can possibly make it. And that's one of the things that makes Salt kind of difficult to debug, okay? So what happens is the local client gets that list, okay, and that's how it knows how to give up, right, how to display information when they come back, right, and how to ask for retries, okay, which are the local client, right, the CLI's 3 main areas of concern, okay. So at this point, right, what we've done is we've taken the local client, right, we've received the args, okay, we've passed those args to the master, okay, and the master has replied with a list of expected minions. Okay? So in terms of troubleshooting, it's extremely uncommon for anything to break here, right? The CLI is communicating with the master over a local Unix domain socket, okay? Now, let's talk about the stuff that's actually kind of interesting now that we've laid the background out, okay? Which is what's happening on the master, okay? We'll draw our master out here. Okay. If you've been paying any type of attention at all for the past, day or two, one of the things you've heard us go on and on and on about are these event buses, okay, right? The master has its own event bus, okay? We'll draw it out here, okay? Call this event bus, okay? Behind the scenes, this is a 0MQ pub sub channel, or rate, which is I'm going to set aside for the time being because it's too confusing in this model, okay? But the idea is that on this master event bus, because if you've looked at a master, right, one of the things that you've realized very quickly is that when you fire up a master, it's not just one process, right, that's multi-threaded, right? It's multi-process, okay? So if you've ever done any type of network programming or multi-process programming, right, you know that, right, unless you're dealing with shared memory in case you kind of want to shoot yourself, you need to be able to communicate, right, between processes on a machine, right? Duh, we all know that, okay? The way that we do that is that we use 0MQ, right, as our inter-process communication bus, okay? and we do it in a pub/sub pattern, okay? Which means that anytime any one of these processes, right, on the master, for the most part, wants to communicate with any other, right, data is put onto this event bus, right, and anybody can choose to listen to it, okay? Now, this is what's happening, right, with the client, right, local client, and the master, okay? Is that as we'll see when we get further along with this story, when the local client is ready to listen to returns, it listens on that event bus, okay? One important thing to realize in terms of troubleshooting, okay, is that you too can listen to that event bus. And I really, really recommend that you do, because it's the fastest way to learn anything at all about Salt internals, okay? So here's sort of troubleshooting tip number 1, which is learn how to listen to the event bus. There are 2 ways, okay, that you can listen to a master-side event bus, okay? The first is that in Salt, we ship Salt core, but we also ship all of the tests, the unit tests and the integration tests that we use with Salt. If you've ever submitted a PR to Salt, you've probably heard from Nicole back there in the back of the room saying, oh, all of the tests passed or they didn't pass, right? So we ship our whole test suite. We also ship some of the debug utilities that we use along with the test suite. One of those is called eventlisten.py, okay? If you fire up eventlisten.py, you can point it to the master event bus, okay? There are just a number of args. It's super easy to use, like it's brain dead. It will start streaming events on that bus back to you, okay? The master event bus is going to contain all types of inter-process communication, right? The master event bus, by the way, is the same thing that the reactor listens to, if you've heard talks about the reactor over the last couple of days, so on and so forth, okay? So the master, it was about in 2014.7.4.5, right in there, that we added the ability to distinguish which process in a process list is running with which master role, okay? So if you're running a more recent version of Salt and you're running a master and you look in the process list, you're going to see things like salt-master mworker, right? Salt-master rec server, okay? Salt-master publisher, okay? If you don't see that when you look at a process list, either you're not viewing extended process attributes, right, which is your fault, or you don't have a recent enough version of Salt, which is, I guess your fault too. I'm just joking. Anyway, those attributes actually map directly into roles, actually classes, inside master.py, okay? There are, like I said, 3 of them that we're going to talk about today, okay? So I'm now going to divide these up basically by process type, okay? We all know, and we're going to talk about this a little bit later, there's a config option called worker_threads, right? Okay. That option directly controls the number of M workers, right? Master workers, okay, which are started. By default, it's 5, but I only have room for 3, okay? You'll also see another class, right, called rec server, okay? And you'll see one called publisher, okay? Right? We all know that when we connect minions to a master, right, that we connect from the TCP perspective inbound to the master, right? Okay? We know that there are 2 ports, 4505 and 4506. Well, guess what? Okay? Right? 4505, right? 4506. Okay? You can probably guess at this point what these 2 classes are responsible for, right? The publisher publishes, The rec server receives requests, okay? From an architectural perspective, okay, and we'll get back to this in a minute, but the rec server, when it receives requests, farms them off to M workers, okay? So, back to our story about our publication that we're trying to send, okay? So, we've got the local client, right? The local client has all of its targeting information, okay? And it's going to tell the master, okay, I want to send test.ping to star, okay? It does so by connecting to the rec server, right? The rec server receives that request, passes it off to one of the M workers, right? Here is where things like EOF happens, right? Any sort of pre-flight determination that could potentially prevent or short-circuit the master from sending that publication, right? Would happen in the during this process, right? The M worker, like I said, mostly authentication, authorization at that point, okay? But the other thing that's happening is that the master is generating this list of expected minions to return, right? It does this because the master is caching grains data, right? Because the master obviously has pillar data, right? And it obviously has information about connected minions. It determines that information about connected minions from two sources, right? First being it actually looks at the TCP sessions which are connected, right? And secondarily, it looks at keys, okay? Right? That's how, and keys is how it associates, right, IDs, right? I want to target foo. Do I have a key for foo? Yes, I'm good, right? If you target Baz and it's never heard of Baz because it looks in its key directory and says, I don't know about Baz. It doesn't need to send a pub, right? It knows Baz has never authenticated to it, right? Okay. So at that point, that list is generated, right? The rec server kicks that list, right, back up to the client. Apologize for this kind of dirty drawing here. And the client is ready, okay? The other thing that happens, okay, right, is it passes this guy over to the publisher, okay? And the publication goes out, okay? So now let's jump back to troubleshooting a little bit. If you run the master in debug mode, which I highly recommend that you do for your own edification, not necessarily in production, but if you want to understand the internals of how this works, do run your master in debug mode. It's really, really great because you'll see these things happen, right? You'll see the publication go out because we'll log it, right? You'll see events fly across the event bus because we'll log them, right? So on and so forth, right? So this whole process should be completely visible to you in the debug log, okay? So obviously, right, if we're diagnosing missing returns, right, and you see a pub never gets sent, right, you should at this point know where to look, right? You could start to put some print statements back in local client, right? Or you could start to look at your log and think about things like, you know, EOF has gone sideways or something of that nature, right? Okay. So one other thing to recognize here is that it's important to remember that that SALT is a broadcast model, okay? That as soon as this publication goes out, it goes out to all connected minions, okay? If you target minion foo, minion Baz is still going to hear that publication, okay? Minions self-select, okay, whether or not they should be acting on publications that they hear, right? Okay, very important, okay? So, we'll return to that page in a moment, okay? And I should say that very rarely do we see any type of problem in this area, right? It's extremely rare for the client not to be able to talk to the master or the master somehow falling down and not responding back to the client and for publications not to be sent out. It's not completely unheard of in the history of all Salt development, but it's not particularly common. Okay. Now, all the way over on the other side of the network, right, we've got our Minion. Okay? Okay. Our Minion, as we know, is connected to 4505 and 4506, which is the publisher and the rec server respectively. Okay? So it hears this request, right? It evaluates, right, the targeting information, as we've just mentioned, right, and says, should I run this command? Okay? If the answer is yes, okay, what it does is it immediately forks a process to do that, right? Why? Because Salt is fundamentally asynchronous, right? Because we don't block, right? Because if we did it in that loop, the Minion would stop and it wouldn't hear any additional traffic, right, until that finished. That's bad, right? So we fork, okay? So at that point, that fork happens, okay, and now you've got a copy of that Minion process, right, with information presented to that process, right, about what it's supposed to do, okay? At that point, this forked process, right, can go about. It's got a list of functions, right, which it looks up, right? You may have seen Dunder Salt, right? It's looking that up in its list of functions, right? And it calls that function, and it does work, right? So it's doing work, yada, yada, yada. That work could involve any number of things, right? Obviously, if this is like a package.install, it involves installing packages, right? This work, however, can also involve asking the master for additional information, right? I.e., this is state.sls. Do I have a copy of this SLS file? No, I need to go back and ask the master for one, okay? You can, again, see this type of traffic happening, right, on the event bus, so on and so forth, okay? Same thing with pillar data, right? Like, oh, I need pillar data. It's going to go out and ask the master, so on and so forth, okay? Anyway, it gathers everything that it needs from the master. Hopefully, a lot of that is cached, right? And then it does the work, okay? Work is finished, okay? At this point, the Minion is ready to send a response back to the master, okay? We're going back, right, 4506, okay? And again, right, you'll see an event, right, as that happens, right, because the Minion has its own event bus, right? Same troubleshooting principles apply. You can still use event listen to connect to the Minion side event bus if you like, right?
Which I have to do on the Minion.
Yes, you do have to do on the Minion, right? Because these event buses are UXD, right? They're Unix domain sockets, right? Okay. So anyway, we kick this back. That process, before it dies, may do a little bit more work, right? It may do things like it needs to communicate with a returner, for example, right? So that may happen, things of that nature, right? But it does try to get that pub back as quick as it can, right? Just to give you some profiling information, usually this whole end-to-end communication in just a test.ping under optimal conditions, we can stand up the CLI, we can get the pub off, we can check for the expected returns, communicate over the network to the Minion, have the Minion do its work, get all the way back to the master and all the way back to the CLI, and display it in a window in about 90 milliseconds, which is not slow, in my opinion. Maybe you consider it slow. I still want it to be faster. And incidentally, most of that work actually is in standing up the CLI, right? Actually, about 70% of that work is in standing up the CLI. So it's pretty fast, which should go to show, right, that if you're seeing a test.ping, right, and it takes, 5 seconds, like you've got some investigating to do, right? Because 90 to, about 150 milliseconds is about your baseline, right, under optimal conditions. All right. Okay. So we are back on the master, okay? And we've connected back to the rec server, okay? All right. Now, as you might imagine, okay, if you do a test.ping of 10,000 minions, right, this guy is going to get quite busy, right? Because everybody is going to answer all at once, okay? Which means, again, non-blocking, right, asynchronous I/O, we can't let this guy block, okay? So again, over 0MQ, right, we use a router dealer pattern, if you're interested in that sort of thing, right, to farm these requests back to workers, okay? The workers are the guys that actually unwrap the request, right, use a returner if they need to, right, and do any additional post-processing that needs to be done. Once that return, right, has been processed by the worker, right back down here to the event bus, okay? Remember, you can be listening to the event bus. Anybody else can be listening to the event bus. But the most important, right, person or not person, but thing listening to the event bus is our friend, the client, right? Who all the way back at the beginning of this story had a list of minions that he expected to return, okay? And return starts streaming in. You've seen the way the local client works, right? It attempts to display that information as it is received, right? Unless you specify -- static, okay? Okay, so now let's get to this question of missing returns. And I guess I should have said about 5 times. Does anybody have any questions about all of this that we've covered thus far? Yeah.
So the request server is actually sending to the workers on the event bus as well?
No, not on the event bus, right?
Can you repeat the questions?
Sorry? Oh, I'm sorry. The question was, does the request server communicate with the workers over the event bus? Right? And the answer was no. Okay. Okay. Any other questions about all of this? Hopefully it's surprisingly simple, right, how all of this stuff works. It's actually, yeah,
So
question.
listening, all the minions listen on the bus, so they get to see all the events happen.
Minions have their own bus, right? But minions listen to communications from the master, which originate from the master publisher.
Do they only see their communication?
They see all communication originating from the publisher. They then decide if that communication is relevant to them. Right? Yeah, question?
So the publisher is listening to the event bus to determine what to publish?
The publisher, let's see, the publisher is listening to the event bus to determine what to publish. Yes, that's correct. Yeah. Question?
So you just said the minions have their own event bus.
Local to the minion. Okay, I'm sorry. Yeah, the question was, do minions have their own event bus local to the minions have their own event bus.
So the minions have their own event bus. Is
Yeah.
that on the remote machine, or is that my real question is who's listening to that event bus?
Right. The minion, because it forks that process, right, again needs an inter-process communication mechanism, right? And so that forked process, right, simply announces, right, to the process which forked it that it has completed. Right now, to the best of my recollection, that's effectively a no-op, right? But it does so, and you can listen to it as well if you like, right? Question?
So as far as the rec server not using the event bus to talk to workers, is what is happening is it spins up a new worker for each task?
No. It has a fan-out pattern, basically, okay? So it's basically doing round robin, right?
So
Yeah.
how does it talk to them?
How does it talk to them? It has its own Unix domain socket, right? It's 0MQ, okay? That is uses the 0MQ router dealer pattern. Yeah.
So
Yeah.
it is using 0MQ, it's just not using the event bus channel on it.
0MQ is the underlying transport both for event buses and for network transport between master and minion, right? right? If you go and you look at 0MQ and the architecture patterns, you'll see them start to align, obviously, right, with the way that Salt works. Any other questions? Okay. Okay. All right. So the local client, right, has this list, right? Obviously, as soon as all the minions that it expects to return have returned, right, it's done. So we ask ourselves, of course, okay, what happens in the condition that it got 8 returns back, but it's expecting 10, okay? What happens there, you've seen a timeout value, right, that can be specified on the command line or actually in the master config, okay? That timeout value, right, indicates the time that the client should wait, right, for a return to be given back to it before it gets nervous and goes out and asks what's going on, okay, right? So it looks at that timeout value, okay. It goes up, 5 seconds have gone by, okay. And then if it hasn't seen a return, it will fire a new publication, okay. And it will ask about the status of that job, okay. Now, if you're paying attention, you probably are going to ask yourself, okay, what's this concept of a job, right? In addition to expected minions, right, this command is also assigned a job ID, right? You'll see JIDs everywhere in Salt, right? In fact, we expose them all the way up to the user level. You can actually perform this same sort of behavior using the jobs runner, for example, right? You can query a JID. You can see via the CLI if you run with -v, right, salt-v, test.ping, the very first thing it'll spit out as soon as it hears this reply back from the master is what the job ID is going to be for this job, okay? So we've got this JID back, right? And now what happens is, okay, the CLI, right, is still looking for information. So it goes out and it says, okay, I'm looking for information about this JID. Same process happens, okay, right? A minion might say, oh, in fact, this work is taking a really long time. I'm legitimately not done, okay? In which case it will respond to that, right? And the CLI will continue to wait, right? Timeout will reset, right? And that will go on, right? So long as that minion is still, legitimately working, or at least telling, right, the CLI that it's legitimately working, the CLI will continue to wait, okay? So, any questions about that? Question?
Yeah, when it does that timeout status
Yeah.
check, does it target all minions, so the ones that were done say I'm already done again?
I believe, I do not remember off the top of my head, actually. I would have to look. I believe it's saltutil.findJob. It's actually an execution module and a function that you could call. I don't recall the implementation. The question was whether it asks all minions for that information or whether every minion should reply. I believe it specifies minions to look for, but I don't remember that code off the top of my head. I apologize. Any other questions? Yeah.
When the minion is figuring out whether the fork process is still alive, it's just looking to see if that PID is still active.
Yeah, the question is, when the minion is looking to see if that's still alive, basically what's the purpose of that? Yeah, and it's the same answer that I gave sort of earlier, which is that it's effectively a no-op right now. It does that announcement effectively if you choose to listen to it or if we choose to implement something later, right? Yeah. Okay. So, anyway, then at that point, if the CLI, once it either has all returns back, right, or if it didn't get a response, right, for that request, that find job request, right, it will give up, right, so on and so forth. Okay. So, because we only have, unfortunately, this discussion takes kind of a long time. We have a couple more minutes. Let's actually get into some real-world troubleshooting tips because that's what was promised, right? Okay. Event listen, okay, is one way to access it. There's also a job runner, okay, which is called salt run. I believe it's state.event. It'll do the same thing, right? It'll stream events on the master, okay? Go ahead.
Why would I care about one? Why would I care which one?
You wouldn't. You know, it's easier, a little bit easier just to use salt run. You would use event listen if you wanted to listen to a Minion event bus, or if you had created some sort of arbitrary event bus that you wanted to listen to, or if you wanted to learn how to write Python to listen to an event bus, I would go out and read event listen. Yeah.
Do those run in the background at all, or are they all run in the background?
Which?
The event list. Or maybe I'm not.
Those are run in the foreground.
Is there a way to make them run in the background so that like they're always running?
I
Running for a given amount of time?
do not think so. Yeah. Yeah. Tmux is one answer, which is a good answer. No, but it would not be very hard to adapt them to do so. Yeah. If you look at the event listing code, I think it just barely cleared like 100 lines, so it's super simple, right? Yeah, so it's not that bad. Secondarily, obviously, and this should go without saying, right, look at debug logs because they're going to show you effectively every step of this process, right? Before I run out of time, I do want to jump ahead to the optimizing side of this because I did promise people. I also want to talk a little bit about Minion Swarm, which I'm not going to demo because I'm terrible at time management. When we get into performance optimization, Minion Swarm is a good place to start. I mentioned salt.tests, right? There's another script in there called Minion Swarm, okay? What Minion Swarm can do is it can spin up an arbitrary number of Minion processes, right, on a single machine and then connect back to a master, right? So if you want to simulate, you know, 100 minions, right, go to town, you can totally crash your laptop doing this. I've done it many, many times, right? Yes, that's a feature. Yeah, you're welcome. But start with like 10, right? Do not start with 1,000 unless you want to be sad, right? But Minion Swarm is very useful for that type of thing. You know, it's Unix, you know this. It's super easy to use Minion Swarm. Okay, so before I run out of time, I wanted to talk about a couple of tuning settings, master side. And to be perfectly frank, there is not a lot of master side performance tuning that people end up doing with Salt. And most of the time, performance tuning does not even become a consideration below 1,000 connected minions, okay? That may not be universally true, so please don't come up to me and say, that's not true. Most of the time, that is true, okay? As you scale up above about 1,000 connected minions, okay, then you want to start to consider some tuning. The first tuning that people tend to consider is worker threads, okay? Now that we understand the master architecture, we know that worker threads correspond directly to the number of M workers, right? Why do we need worker threads to scale up? Because we don't want to block the rec server, right? That's bad, okay? To give you an idea of worker thread scaling, right, to the best of my knowledge, we do not have anybody using Salt in production with more than 30 workers, right, that I'm aware of. Like 50 workers would be insane. You would be like LinkedIn, right, or bigger, okay? Or you would be scaling horizontally, right, in some other direction, okay? So a reasonable thing to do is to go from like 5 to 8 or maybe 5 to 10, not 5 to 500, okay? Okay. One of the things that the master does is it can cache jobs, okay? And it can cache jobs such that you can query that job cache later and say, hey, what was the result, right, of this job that ran overnight, okay? If you run a lot of jobs or you have a very busy master, this can hit the disk pretty hard, okay? So by default, right now, we keep jobs for 24 hours, to the best of my recollection. if you have an extremely busy master and an extremely busy job cache, which, you know, your sysadmins, you ought to be able to see that real quick, right? You'll know about it, and you'll want to turn that down, okay? Another option is known as the loop interval, okay? That controls the maintenance cycle, okay? There is some cache pruning, things of that nature, okay? Potentially, you can turn that down if you have a very, very busy master, right? And you want that maintenance to happen potentially a little bit more often. So, which is basically just a smoothing approach, right? Like you don't want to wait too long. And like if you have a master that looks like this, right? That could be one place that you could look, especially if it's doing that every 60 seconds, then you know, right? Timeout, we talked about timeout already, okay? Max open files, if you're using rate, this should not be a consideration. If you are using 0MQ, this is a consideration. The reason being that the way 0MQ achieves its scalability, right, is by, basically it's by using threads connected to sockets, right? The problem is that it uses an insane number of file descriptors, right? If you hit that file descriptor limit, right, A, you should know because you're sysadmins, right? Like that should be easy. But Salt will get extremely angry at you and terrible things will happen, right? Namely, networking will just go completely sideways, right? So yeah, don't hit that limit, right? And so obviously, basically that limit ultimately just ends up calling like resource dot, you know, set our limit or something. You can achieve the same sort of thing just by doing ulimit, right? Same idea. Okay. That's all the tuning stuff I have. To the best of my knowledge, we are out of time. Yes. Yeah, pretty much. Are there any additional questions? I know that we didn't address troubleshooting specifically, but it's sort of my hope that an architectural overview will help you to at least understand the moving pieces enough that, that you can start to dive in and be able to figure things out if they go sideways. Question?
Is there a similar configuration for the minions? Is it as a scheduler? Is it,
There are. It's extremely rare that we see performance considerations on the Minion. I really can't remember the last one that I diagnosed. Most of the times because the Minions, right, you know, it's non-blocking, right? It forks this process and it does work, right? Like, what are you going to tune about that? There's just not that much there. So for the most part, we don't see Minion side tuning as much of a consideration.
in reference to the reactor? And so now you have all these events that can be triggered off.
Right.
Going to minions.
Mm-hmm.
Some of them attacks the master.
Right. The event bus, they scale pretty well. You know, I don't think we've really run into an instance where we've just seen the event bus just completely tipping over. If you have a case of that, we would certainly love to see it and help you try to fix it, but we don't see it much in the wild at all. You know, the question was whether or not there should be any concern about like the Minion event bus side tipping over, and I was just saying that we don't see that much at all. Question?
Originally, you had said that the master knows when to stop waiting for events when it knows all the minions.
Right.
But in a Syndic scenario where it doesn't know who's on the bus, you see that it always waits till the timeout for that the intended behavior occurs?
There are a couple of bugs around that issue, so I'd probably want to look at your particular use case and figure out exactly what's happening.
So the master is supposed to know through the Syndics who should be responding?
That's the best of my recollection, yeah, right. But like I said, we've had a couple of bugs around that issue. I think a number of them have been worked out in 2015.2, but that should be the model, yeah. Sorry, question?
Sometimes I've seen situations where the medium doesn't
Mm.
so you simply get the phone back and
Right.
nothing happens.
Right. So the question is, it seems as though sometimes nothing happens if you know, you send a command and you got nothing, right? The first thing to do, obviously, is you know, use our newfound knowledge to look at debug logs, right, and figure out where in this process things stopped working.
I found out
Okay.
it's actually doing something.
Okay. It was actually doing something.
It doesn't show up.
It doesn't show up, right. So in all likelihood, that could be a bug in the CLI. You know, if you see something like that, we need to be able to see debug logs, right, from the master and from the minion, and ideally from the CLI itself, which you can also run with a debug flag. Yeah. Question?
I saw that behavior happen with the people distribution to 2.14.7.0, but 7.1 seemed to have fixed that.
Yeah.
And it was stated that previously when I looked at this problem that it was 0 to 2.0, but 7 is using 3.
Yeah, and that's a very important consideration. Thank you. He was saying that that was a problem in some of the early 2014.7 releases, and we did make a lot of progress on that issue in 2014.7 over the course of its lifetime. And that's something that I wanted to mention too, which is that we make progress on these issues all the time, and that very, very often people solve these issues by upgrading. And that's not just me waving my hands and saying, run my newest, greatest, latest code all the time, because I know how that sounds. But we do continually do work on this stuff, and it does improve over time. The last thing that I want to say about that is that there are known problems with 0MQ3. We strongly recommend that you do not run 0MQ3 in production if you can help it. I know that there are packaging considerations on some distributions. We've been trying to work around that. But if you have any option at all, we strongly recommend that you run 0MQ4 in production. Yeah. Or rate. Or rate. Yeah, please do. Yeah, right. Yeah. I think that's all the time I have, so thanks very much for coming. I'm happy to answer follow-up questions later.